will discuss 3-4 paper of May June 16. Borax is an alkali which has many uses. Please underline the main points while performing the question. This is an alkaline solution. Borax is an alkaline solution which has many uses. In this experiment, you will determine X value of X in the chemical formula of borax. This is the chemical formula by titration and hydrochloric acid. Fb1 is a solution containing 15.5 gram dm cube of borax Na2BxO7 10H2O. Fb2 is 2 mole per dm cube of HCl. Methyl orange indicator used as an indicator. Please keep it in mind that indicators are in acidic nature. Pipette and use 2 to 3 drops. 2 to 3 drops. Please keep it in mind that 2 to 3 drops of indicator, not more than 2 to 3 drops. Okay. Now method is dilution of Fb2. Pipette 10 centimeter cube of Fb2 into the 250 centimeter cube volumetric flask. Like pipette, you know that pipette. This is the pipette. Pipette out 10 centimeter cube of Fb2 in 250 centimeter cube. This is the dilution. This is the titration flask. This is 250 centimeter cube for volumetric flask. So pipette out 10 centimeter cube of Fb2 into 250 centimeter volumetric. Make the solution up to 250 centimeter cube. Fill this flask up till 250 centimeter cube of distilled water. Shake the solution in the volumetric flask thoroughly. This dilution solution of hydrochloric acid is Fb3. Now this solution marked as Fb3. Label the volumetric flask Fb3. Titration. Fill the burette by using filter funnel. Fill the burette by using filter funnel. Starting from 0 and over here 50 centimeter cube. So fill the burette with Fb3. Mean to say that borax solution is Fb2 is hydrochloric acid. So hydrochloric acid is in the burette. Pipette 25 centimeter cube of Fb1 into conical flask. This is conical flask. This is conical flask and pipette out 25 centimeter cube of Fb1 into a conical. Fb1 is the solution of 15 gram per dm cube of borax. Fb1 into conical flask. Add several drops of methyl orange. Now in this case add several drops, many drops of methyl orange. Perform a rough titration and record your burette readings in the space below. Final burette reading is 25. Please draw the table like this. This is for rough titration table, and table you can get 4 marks for drawing the table, and write down final burette reading. Centimeter cube volume unit is always very important, and write down the readings in 2 decimal place, 24.90, 0.00, and volume of Fb3 used per centimeter cube. So we are taking Fb3 in the titration flask. Fb3 is hydrochloric acid, should keep it in mind. The rough titer is 24.90. Carry out as many accurate titration as you think necessary to obtain consistent results. Make consistent mean concordant result, mean the difference between two reading is 0.00 or it can be 0.10, not more than 0.10. So, final burette reading is first row is final burette reading, centimeter cube is the unit, second row is the initial burette reading and centimeter cube is the unit. Write down the unit, don't forget to write down the unit. Volume of FB3 used along with unit, and you can get this mark, this mark, this mark and this mark when you draw accurate table for the titration. So, we have two reading to take. These are the best. Make sure draw the another column for best titration. This is the best titration. Best titration. So, this is these two readings are the best titration because difference in between these two reading is 0.10. So, make sure that difference not more than 0.10. These are the concordant reading. From your accurate titration results, obtain a suitable value for the volume of FB3 to be used in your calculation. Show clearly how you obtain this value. Now, show your calculation over here 24.50. Don't write the direct volume of average volume over here. Show your calculation 24.50 plus 24.60 divided by 2 because you are taking two readings. So, this is the average volume of 24.55. Now, calculation. Show your working and appropriate significant figures in the final answer to each step of your calculations. Calculate the number of moles of hydrochloric acid present in the volume of FB3. So, we know that FB3 and FB3 is dilute solution of FB2. So, we have FB2 concentration and volume 2. We have taken 10 centimeter cube of FB2 and dilute this solution, and concentration is 2 mole per dm cube. So, this is the concentration of FB2, volume of FB2 is equal to concentration of FB3 and concentration volume of FB2. So, there is 250 centimeter cube of we have taken 250 centimeter cube of we have to fill up in dilution. This is 250 centimeter cube. We fill this solution till 250 centimeter cube. So, the volume we have taken 250 divided by 1000, concentration you have to find out concentration. So, concentration is equal to by using by calculation this we have called concentration, that is 0.0800 mole per dm cube. So, this is the concentration of FB3. Now, use this concentration over here to calculate the number of moles of FB3. Volume is 0.02455 dm cube, and always you should be particular in significant figures, always taking 3 to 4 significant figures in context of this calculation, like 0.02455 dm cube is the volume. So, volume we know that this is the volume 24.55. So, this is the volume in dm cube. So, we can get 24.555 divided by 1000. So, in this way we get 0.02455 dm cube. Number of mole is equal to concentration into volume. So, we have moles of HCl. Concentration is we calculate this concentration and use in this in calculation of number of mole. So the answer is 1.96 into 10 raised power to minus 3 moles of HCl. 1 mole of borax is neutralized by 2 moles of hydrochloric acid. Calculate the number of moles of borax that react with the hydrochloric acid in 1. Mole ratio is base ratio, borax ratio HCl. Borax has 1 mole. We have borax is 1 mole. So it is given over here 1 mole of borax is neutralized by 2 moles of hydrochloric acid, 1 ratio 2, and X is equal to 1. So we have calculated mole over here. So the answer of borax is 9.80 into 10 raised power to minus 4 moles. Use your answer to 2 to calculate the number of moles of borax in 1 dm cube. So we have number of mole is 9.8 into 10 raised power to minus 4, volume is 0.0250 dm cube. So the concentration is mole over volume. So this is the mole and this is the concentration. So we have 0.0392 mole per dm cube is the answer. So this is the mole of borax in 1 dm cube of FB1. Now use your answer to 3 and information on page 2 to calculate the relative formula mass Mr of the borax. So this is the information from page 2, and you know this is 15.5 gram dm cube of ore. This is the mass of borax. So by using the mass of borax we calculate the Mr. Mole per dm cube is 0.0392 and gram per dm cube is 15.5 dm cube. So Mr is the in mole per dm cube is equal to mole per dm cube. First convert this into gram per dm cube over Mr to calculate the mole per dm cube. If the concentration is given in gram per dm cube, so should always grams, amount of grams like 15.5 divided by Mr of borax. So in this way we convert this quantity into mole per dm cube. So Mr is equal to gram per dm cube over mole per dm cube. So 15.5 gram per dm cube is the concentration of borax, and divided by mole, we use this mole, and the Mr is equal to 395.41 of borax. Calculate the X in the formula of borax. We have to find out Bx. So calculate the Mr of this compound. We have sodium is 23 into 2 46, oxygen 16 into 7 is equal to 112, and water is 18. So water 18, and the 10 moles of water, so 10 into 18 is equal to 180. So the total Mr is 338. AR of borax, AR of boron is 10.8. So 395 is equal to 338. So this is we can say 338 plus 10.8b is equal to 395. So in this way we get boron is equal to 57, like this, 57 over 10.8. so this is the 57 point, and this is the boron value. So this is the value of X, boron. So in this way now we will write down this formula, Na2Bx instead of X we write on B5 and O7 10. Is it clear to you? So hopefully you clear this mole question.